Okay, let's move to the next half. We're going to look more about the matrix operations. Now again, let's start from a simple application. To estimate the total weight of the shark in each month for both type WTS and the BTS, and we made an estimation. The average weight of WTS is 20 kilograms, and the average weight of BTS is 18 kilograms. So now, in the first month, we remember we have 20 of WTS, 15 of BTS, and then the total weight. We did this before when we learned the vector calculus, and then we just do the dot product. We got a total of 670 kilograms. Well, now let's write into a matrix form instead of a vector form. Then the first matrix need to be write into a row. That's a 1 by 2 vector. And the second one is a 2 by 1 vector. And then, just like a dot product, now we call it as a matrix multiplication. You are going to get a 1 by 1 matrix. That's actually a scalar, and it's the 670. And we did that before, but we call it a vector dot product. But we can compute a little more of this. We can compute every single month and to see the total weight of the two types of sharks. And then on the left hand, I have a 6 by 2 matrix. On the right hand, I have a 2 by 1 matrix or vector to represent the weight. So no new idea. The first times this is the dot product, and the 20 times 20 plus 15 times 18, you got this 670. The second one, we got the 6.57 times 20 plus 527 times 18. It's the second row times the first column. You only have one column anyway. You got the 228. And so on and so forth. What you really did was multiply a 6 by 2 to a 2 by 1 matrix. In the end, the result is a 6 by 1. Now, this you call it a vector, but we look at it as a matrix. So you got the idea. So we extended the concept of dot product to the matrix operation. And what you should observe is the number of rows in the number of columns in the first matrix equal the number of rows of the second matrix, because these two need to match in the dot product. So let's generalize the idea of matrix multiplication. Well, we're going to give you more examples, but let's generalize the idea. If I have the first matrix A which is a M by Q matrix. So if I expand it, let's say the M equal to Q equal 4 and the N equal 3, that's a little easier for you to follow. So I can randomly give you something, M equal to Q equal 4, all right. So that's the first one. It's A. It's 2 by 4. And the B is a 4 by 3. So let me randomly give you something else. Let me put a lot of zeros. That make it easy to multiply. And then your final result is going to be a 2 by 3 matrix. The first thing you need to check if it's doable or not is the middle one, Q, the column of the first matrix equal the row Q in the second matrix. That Q equal 4. That's the checkpoint before you do the multiplication. Other than this is a dot product. The first element, we said it's a skeleton, right? Let's put it the skeleton, and then we fill in the numbers. So the first position is the first row, first column. Then you make this first row, multiply this first column. Now it's very, oops, I missed one thing, right? Yeah, it won't work. I need another one. 4 rows. Otherwise, you see, if I miss one, I cannot do it. Multiply. Now, the first element is 1 times 0 plus 2 times 1 plus 3 times 2 plus 4 times 0. And you know the number is going to be 2 plus 6 is 8. I'm not going to do all of them. Let's select this element. That will be the second row, the third column. Then you select the second row. You select the third. Oh, that's the second row, second column. And select the second column. That's how you multiply. You have the, let me put it here, 0 times 1, 1 times 0, negative 1 times 0, plus 2 times 1, and they actually equal 2. And you can finish the rest of them. So to identify this IQ, all you need is understand what that means. So let's go to the general concept, the Cij. So the AI row, sometimes you put a point, that means the whole row. In MATLAB, to write the, let's say the second row, you write as this. I think it's parentheses. Second, common, dot, semicolon. That means you're talking about the whole second row. To talk about the speed, the second column, you're going to write it as dot, that's the whole row, common, and the second. And then when you multiply, then you just multiply like this. That's in MATLAB. Then you're going to get this result. In general, if I get the AI row times the BJ column, let me put a point, or say dot, like that. And then you get this element, Cij, if this A times B equals C. Well, the C in this case is going to be an m by n matrix. And I jump to here. What you are really doing, I don't care about what is the rest. The A1, this is A11, AI1, AI2, AIQ. And the B matrix I write in 2 columns. And then this one is B1J, B2J, QJ. So the result, let me get a little bit more paper. Oh, here you go. And then the result is the dot product, AI, no, this AI, a little bit messy, dot BJ, you learned the dot product. Let me write a little better. AI, that's the row here, dot BJ, which equals AI1 times B1J, AI2, B2J, you got the idea. And the AIQ, BQJ, again, you see why. This is important. This Q need to equal.